All right, hello statistics students. Welcome back in. Today we are talking all things conditional probability, so section 4.2. In this ed puzzle, you're going to be able to understand probability notation, calculate marginal probabilities, and calculating conditional probabilities. So the big thing is here, all right, you're going to notice some of this stuff is actually from the last class, but I really wanted you to hone in on this. So what we're going to do today is the big thing we're going to talk about is we're going to discuss the difference between marginal probabilities and versus conditional probabilities. So let's go ahead and get into it. Okay, so if we're looking at this, so understanding probability notation. So some of this is going to look familiar here, all right? So a friendly reminder that we write probability as P, and in parentheses we put an event, right? So whatever the event we're trying to occur here. So if I'm just trying to find the probability of event A, right? We write this as P sub A. Right, and that says the probability that event A will occur out of the total, right? So what I'm going to do is I'm actually going to draw a quick cross-tabulation table, which is from chapter 3 that you guys are aware about and what we kind of did last ed puzzle. So give me 1 second while I catch my feet here. Oops. Sorry, Mrs. Ward. Okay, so we're going to have event A here, event B here. Oh, I'm sorry, that's wrong. I'll do that. Event A, not A, all right, event B, and event not B. We'll get into this later, but this A to the C and this B to the C, that's just how you write the complement. We'll talk about what that is later. So don't worry about it right now. Just think of it not A and not B, right? So we know if you have, two variables, right? You have your total here for this column. So this is A total, right? This is not A total. This is going to be B total. This is going to be not B total. And then in this lower right-hand corner, this is the grand total, right? So if I'm trying to find the probability of event A, I'm going to take my A total and divide it by my grand total, right? But if I wanted to find the probability of A and B occurring at the same time, well, that's going to be in this box right here, A and B, where I would take the grand total of whatever this number is and divide by the grand total, all right? Now, okay, both of these, all right, so this first one was the A total divided by the grand, right? This number was this number divided by the grand total. Both of these are marginal probabilities. And the reason why they're called marginal probabilities is because they are both taken out of the total. When you hear the word marginal probability, I want you to think of out of the total, right? So that applies to this and that applies to this. Okay, now let's talk about what this is. Now, again, we discussed what this means last ed puzzle, but this is a friendly reminder. This means that the probability of A given that B has occurred. What that means is the probability of event A out of the total B. So if we wanted to find this number, what we would do is we would take, if I wanted to find the probability of A given B, so this stands for A given B. Let me change my thickness of the line real quick, sorry. Given B. All right, what I'm going to do is I'm going to take this number, because this is my A out of my B, correct? And I'm going to divide by this number. Okay, so that's just how the numbers work differently. All right, again, we have done cross-tabulation tables already, but you're going to see how it goes. All right, so this is what we call a conditional probability. All right, when we take the event given that another event has already happened. All right, on condition. Get it? On condition. Okay, sorry, that joke is bad. Anyway, moving on. So let's calculate these marginal probabilities, all right? We're given a cross-tabulation table. Again, we've already done this. Now, instead of writing percent, we're just going to write the fractions or probabilities, all right? So we're looking at this, right? Probability that someone is a freshman, all right? So if I'm looking right here, here's my freshman column. Here's my total number of freshmen, 137. So the probability of being a freshman is 137 out of 388. And you can leave it like that, or you can convert it to a decimal. Remember, no percent here. We're talking probability. All right, now let's look at the probability of being on campus. So now I'm going to look at this column right here. This is my on campus. So there's a total of 157 students on campus here. So that would be 157 over 388. All right, next thing what I'm going to do is I'm going to look at probability of being a junior and off campus. Now notice this is not a conditional probability because we're just asking, all right, well, what's the total number of people that are juniors and off campus? So a good way to do it is, all right, here's my junior column right here. Okay, here's my off-campus column right here. Where's the number that they meet? Oh, they meet at 90. So the probability of someone being a junior and living off campus is going to be 90 over 388. All right, now again, these are called marginal probabilities. So notice how all three of these probabilities are out of 388. Okie dokie, your turn. All right. And puzzle question number 1. Do you believe in Martians? Here's a survey of 100 college students asking that very same question. Do you believe in Martians? All right. Please calculate the probability of those who said yes. Alrighty, moving on. So the total number of yeses, if we look here, is 48 out of 100. That's the probability of yes occurring. All right. Now let's do some conditional probability. This is different here. So now what I'm going to do is I'm going to look at, I'm not going to be dividing by the grand total here. So if I'm looking here, let's start with this first one. The probability of being a freshman given that you live on campus, okay? Now what I'm going to look at, I am totally just going to be looking at this column. I'm only concerned in this column right now because on campus has to have occurred, all right? So now I got to look at, all right, what's the probability of being a freshman given it's on campus? Well, now our new total is 157. And we see that there's 100 freshmen out of 157, which makes sense, right? Most freshmen at college campuses live on campus, right? How about the probability of being on campus given that you are a freshman? Now that changes. Let me get to my eraser and erase this column. Now the only column or row that I am concerned with is the freshman. It has to be given that a freshman has occurred. Given that you are a freshman, what's the probability that you live on campus? All right, so you're not going to flip-flop these two. It's a totally different probability. Now instead, oh, it's 100 out of 137. All right, so note the two totals are different. And last but not least, what is the probability that you are off campus given that you are a senior? I'm expecting this to be pretty large. So here's my senior column, right? We will only want our senior column here, or row, right? What's the probability that they live off campus? And you see right there, oh, 62 out of 63 live off campus, right? That's huge, all right? So that's the difference. These are all conditional probabilities. Notice how the totals are all different, where if we have marginal probabilities, if I go back here, right? These are all out of the grand total, okay? So you're gonna practice that. Puzzle question number 2. What is, given the same question, what is the probability that they say yes, given that they are a male? All right, so my yes, my male column is 42, and that's going to be 10 males out of 42 said. Okay. Now, again, this one, yes and male. Notice how these two are different, right? What's the probability of yes and male? All right, so the top number is still going to be 10, but this is yes and male right here. Okay, this is not a conditional probability. This is a marginal probability, so I'm going to divide by the total 100. I did that intentionally because I wanted you guys to see the difference, that the probability of yes and a male is different from the probability of yes given that you are a male. Those are two different probabilities. Okay, that's all I got for you in this ed puzzle. Ran a little longer than I wanted to, but it's still way shorter than 4-1. So I'll see you guys in class where we're going to talk about hair color versus car color, and we'll do some practice problems. I'll see you guys in class. Have a wonderful day.